Now, whenever you talk about multiplying, you also need to talk about kind of undoing that multiplication, and that's called factoring. Now, the most fundamental type of factoring is pulling out the GCF. And of course, GCF stands for greatest common factor. So what does this look like? So let's say that I asked you to find the GCF, greatest common factor, of this polynomial. Well, what we're effectively doing here is, remember, when we're talking about multiplication, we've used the model of area equals base times height. And in the past, what we've been doing is we've been taking a base and height and turning it into an area. What we're going to do now is take an area and turn it into a base and a height. So this then must be our area. So I'm going to use the same rectangular model that I showed you before, and my area needs 2 slots. And again, I'll separate this out. This is my scratch work down here. So I have my 2 spots. I'm going to put my 2 terms in there. And then what I'm going to do is I'm going to go through a piece at a time, kind of a like piece, similar piece at a time, and I'm going to find what they have in common. So the first thing I'm going to do is look at my integer values, or the known values, the coefficient. I have a 12 and a 3. I know that those have a 3 in common. 3 goes into both 12 and 3 evenly with a remainder of 0. Moving right along, if I look at the x cubed here, well, that means I have 3 x's, and here I have 2 x's. That means both of them can be divided by 2 x's. And then lastly, the y, well, the y is going to be a little more problematic in that this first one has a y, but the second one doesn't, so I can't pull out a y because the second term here is not divisible by y. So now all I have to do, and this is the beauty of this method, is 3 times what gives me 12? Well, that's just 4. X squared times what gives me x cubed? Well, that's just x. X squared times x, well, that's x cubed. 3 x's. And then 1 times what gives me y? Well, that's just going to be a y. And so now, if hopefully you're noticing, based off of that previous, the previous example where I went from the 2 factors to the area, the base times the height to the area, we're just working backwards here, but it all fits into this system. You've already seen this. So now we'll do the second example, and well, that one's actually pretty easy, but I'll do it in order again. We've got the 3 times what gives me 3, well, that's times 1. And x squared times what gives me x squared? Well, that's also 1. So this is really just 1 right there. And so now I have my 2 factors. I know that the area here is just equal to my base times my height. And traditionally, you kind of go in order. This is a monomial. It has 1 term. And this is a binomial with 2 terms, meaning I have to group it together. But as we've learned, the order of multiplication doesn't matter. These are, of course, equivalent. But now I've rewritten my area as a base times a height. Or more mathematically, or kind of more traditionally, I've written my polynomial as a product of 2 factors. And that's it. That's the basis of factoring. Again, I know some people are a little hesitant to follow this little organizational trick, but it really helps you stay nice and organized and will work for pretty much any polynomial, both forward and backward.